Welcome, calculus students, and this is the next assignment for changing from position to velocity. And I've tried to do a split screen with the My Math Lab on the left side, and hopefully my work is on the right. Hopefully everything's legible and you can see everything. Definitely, again, if you have questions or concerns about anything, you can either email me or text me. I will have office hours from 9 a.m. to 10 a.m. every single morning on the weekdays. So if you'd like to get together and do a Zoom or do a online lesson, I really don't mind. Definitely, I enjoy the company, enjoy the everybody there. So, all right, let's go through the whole process, basically what's going on, and I'll try to highlight some of the key parts to this. So we're going to answer, first of all, question A. And this is going to be very, very similar to yesterday's homework, so there's not much variation. Make sure you get the notes off of the PowerSchool. I made a Word document, and there's a formula, and I'll even include it in this here shortly. So what I want you to do first is identify what is the velocity, the graph of it. Apparently I cannot write on it, so I'm not going to do that. Graph the velocity of the function and determine whenever it's moving positive and negative. So looking at this, you should know that it's linear. So knowing that the graph is linear, I'm going to just make a small graph of it. Nothing special here. You know it's going to start off at 8. Since it has a negative slope, it's going to decrease. It's going to look something like that. That's the general shape of the graph. So I can kind of pick out a couple of these that that looks kind of close. That looks kind of close. Obviously, B and D are very close to the graph, what I'm trying to model there. I just got to kind of look at the graph and figure out which one's which. It looks on the y-axis, they're counting by 2s, so it will be answer B there. There's my answer. Now, when they say when is it moving positive, when is it moving negative, well, the positive is just the region that's above the graph. This is the positive movement, and the region below it is just the negative. Well, I wish I just knew what was that x value right there. If I take the equation and just set it equal to 0 and then solve it, I actually get an answer of 2, which is the x-intercept where it crosses. So when it says, when is it moving positive, the positive is going to be from the x to what x value. And since up here, real quick, something you should take note of, since these values, the constraints are like including those values, you have to put an equal sign with those. So looking at it, I have A and C as my option. They're both 0 to 2. But I'm going to choose C because it says including 0, and that's because of my constraints. So definitely watch out for that. Something you should be kind of concerned with. Now, when is it moving left? Well, again, it's just going to be from 2. Let me get my other marker back, from 2 to 4. But I definitely want to, again, include, let me get back to this one, the 4 in there, make an equal sign. So it's from 2 to 4. And it looks like it's either C or D. In this option, it is C for that. Now, the next part, it is kind of redundant. You're actually going to get the exact same answer over and over. First, what they want you to do, and I'm going to do this in a blue color, they want you to find the antiderivative of this. So we're really just taking this equation, I'm not going to rewrite it, and just find the antiderivative. Well, we're just going to follow the rules where we just take and add 1 to the exponent and then divide by that denominator. So the first one's going to be 8t minus 4t squared over 2. Obviously, they want me to reduce it and simplify, so I'm going to reduce this, and it's going to become 8t minus 2t squared. Now, technically, I should have a plus c with this. Now, since up here they give me the initial value, they're telling me, and I'm going to go ahead and fill in that s of t right there. If I take 0 and plug it in for the t values, I'm going to take and plug 0 in, and then take that 0 and set it equal to it. It's really just going to read 0 equals 0 minus 0 plus c. And I'm hoping everybody knows what that's going to turn into just from basic arithmetic there. Let me go back to my pen. It's just going to be c equals 0. So my final equation here is just going to be s of t equals 8t minus 2t squared plus 0. I'm pretty sure you don't have to put the plus 0 in there. If you want to try it, go ahead and do so, but you might get it wrong, so just be careful with that. 2 squared, and that should be my solution. And there's my answer. Now, the next problem, and again, it's really asking the exact same question. It's really not doing anything different. This is what I did in blue there was the antiderivative. What I'm going to do in green is basically what they're talking about with the fundamental theorem of calculus, and that's this formula, that S of t equals S of the initial value is given to you, integral 0 to t Vx dx. Well, technically, you're going to just take the velocity in the initial and plug it in and then actually solve it. What was the constraint? 0 to 4. So really this is just going to be, let me go back to that. Let me zoom back in. There. And basically what that looks like is just going to be 0 plus 0 to 4, and the equation, oh dang, I forgot what the equation was again. 8 minus 4t. Let me go back to my pen. 8 minus 4t dt, and then we just have to take the antiderivative. But guess what the answer is going to end up to be? The exact same thing. So nothing really changes on this. 8t minus 2t squared. So really when you take the antiderivative and then just solve for the c value, that's just taking the antiderivative. But when you do the fundamental theorem of calculus, it basically is a formula that they're giving you what's the initial value, solve for the antiderivative, the integral, and you get the same solution. So nothing different there. The very last part here, and that one's always going to be yes. Does the antiderivative match up with yes? And yeah, that's correct. And for the last question, they're going to ask, what does the graph of the position look like? The position is, again, the S of t, so they're looking for this. Since it's squared, it's going to be a parabola. Well, all 4 of our parabolas. Since it's negative, it's going to be an upside down parabola, so it's either A or D. Well, D goes into the negative region. If you remember my constraint was from 0 to 4. So really this is the position, and that's my final solution there. So, all right, I have a little bit of time. I don't really want to go over 10 minutes here. I'm going to look at one of the trig problems here. Let me go back and I'm going to scoot this up a little bit so we have a little bit of space. Now, just understand whenever you're graphing or going through, it's really the exact same thing. I'm not going to go through this entire problem, just the beginning part of it. And again, they give you a constraint from 0 to 2 pi, and they give you the initial value. If you notice, the initial value is at times 0, it's at 2. That's where it starts off at. That's the initial. So when you look at this, the first thing I want you to do is graph the velocity function. Well, again, when you graph sine always starts off at the origin. So looking at all of my pictures, it's either A or B. Well, the difference between A and B, A goes up and it increases and then goes down, and B goes into negative and then it goes up. So basically, since I have a positive there in the front of my 5, it's going to be A. And then you just have to fill in the blanks here. And when is it, just a sec here, try to scoot that down. When is the value going to be moving in the positive direction? And again, it's just whenever it's above the graph. Since it goes from 0 to 2 pi, let me get a picture here. Since my picture looks something like that, it goes 0 to 2 pi, well, the halfway mark is just going to be pi. So what my constraint is, and when you write it in here, and I just have one region. You'd only choose A if you had like 2 different regions, if it kind of continued on. But we only have one region here from 0 to pi. And it would just be 0, including equal to there. Make sure you put t in there. Do not put x. If you put an x, it will definitely count you wrong. And then pi, you can just type in actually pi for pi. Check answers. Oh, no. And check everything. Since, I got to go back to that. Let me change this. There it is. I don't want to include 0, I'm sorry for this one, because at 0, it actually equals 0 I don't want to include that exact same point. So it's just a less than sign. So, all right, if you have any questions or concerns, definitely contact me. I don't want to go over 10 minutes with this, and I'll try to save this as a YouTube or another file so you don't have to download it. Thank you. Have a good day.